Hello, we're going to take a look at 9.4 section, which is arithmetic series. Before we get started, I want to just go through some terminology with you. So arithmetic, we've already learned in this chapter, means that the pattern is adding or subtracting by the same number. And then geometric, we've learned, is when the pattern is multiplying or dividing by the same number. So some more terms. Series is when you have a sum of terms of a sequence, where a sequence is a pattern separated by commas. So up to this point, 9.2 and 9.3, we're working with sequences. They were all of the patterns were separated by commas. Now the series, this section and the next section, they're going to be still patterns, but they're going to be separated by plus signs. Now infinite means, or finite, means that you know the first and last term, and infinite means that it keeps going without end, so you don't know what the last term. So a lot of times on an infinite one, you'll see the ... that it just is going to keep going. Alrighty, so for this first couple, we're going to go through, and I want to just practice whether they are a series or a sequence and whether they're finite or infinite. So for this one, notice they're separated by plus signs, so that tells us it's a series. And then we know the first term, we know the last term, so it is finite. The next one, they're separated by commas, so we know it is going to be a sequence. And then there's a ... meaning the pattern keeps going, so then it is infinite. The next one's separated by plus signs, so we know it is a series. And then from there, there's the ... but we do know the first term, we know the last term, so we can fill the ones in between. So for this one, it is a series, so it's separated by plus signs, and we know the first and last term, so it's finite. And this last one, they're separated by commas, so it is a sequence. And then we know the first term, we know the last term, so it is finite. Alrighty, now we're going to find the sum of the arithmetic series. So it says, find the sum of the even integers from 2 to 100. So with this being said, we want to use our sum formula. So we have S of n equals n divided by 2 times a to the 1 plus a to the n. So for this one, if we're going from 2 to 100, and we have the even numbers, think of how many even numbers are between 2 and 100. Half of them would be even, half of them are odd, so there would be 50 even numbers. So since we know, then that means our n is going to be 50. So we can substitute 50 in for all of our n's. Now from here, once we plug in our 50, the s to the 50 means what is the sum of the 50 terms. We're trying to solve for that, so that's going to be our missing variable. And then we're going to have 50 divided by 2 here. Our a to the 1 is what is our first term, so that is 2. Our a to the 50 is what is our 50th term, and that is 100. And then from here, we're going to just simplify this down. So we're going to do inside the parentheses first. So we have 100 plus 2 is 102. And then 50 divided by 2 is 25. Then we're going to take 25 times our 102, and we get 2,550. So that means if we go ahead and add all the even numbers from 2 to 100, our total is going to be 2,550. That's going to be a lot quicker than going ahead and trying to type into our calculator all of the even numbers. So let's try another one. For this one, again, we know it's a series because it's separated by plus signs, and it's finite because we know the first and last term. So we're going to use our finite arithmetic series formula. Now for this one, we don't know how many terms there are from 4 to 99 with the pattern of adding 5. So we're going to first use this equation to figure out the number of terms. So we need to solve for our n. So we're going to plug in everything that we do know. So our a to the 1 means what is our first term. We know that is 4. So we're going to plug in 4 for that. Our common difference, notice the pattern is adding by 5 each time. So our common difference is 5 here. Now our number of terms, we don't know how many terms there are, so then we're going to keep that. But then the term number that we're trying to solve for is 99. What term is that? Is that the 50th term? Is that the 25th term? So we're going to plug in 99, this last term, in for here. And what that's going to allow us to do is see what term number that 99 is. So we're going to have then just the one missing variable, so we need to solve for n. So we want to go ahead and distribute the 5. So we bring down the 99, bring down the equal sign in the 4, and then 5 times n is 5n, 5 times negative 1 is negative 5. Then we want to combine our like terms, so negative 5 plus 4 is negative 1. Then we're going to add that 1 over, and then we get 5n equals 100. Divide both sides by 5 when we get n equals 20. So that means 99 is the 20th term, so there's 20 terms. Now we can go over here and find what the sum of those 20 terms are. So then we're going to plug in 20 for all of our n's. So this s of 20 just means what is the sum of the 20 terms. We're trying to find that, so that will be our missing variable. And then 20 divided by 2, we're going to just put 10 there. And then our a to the 1 is what is our first term, so that is going to be 4. And then our a to the 20, what is the 20th term? That was our last term, so 99. So we're always going to be plugging in our first term and our last term here. So then it is 10 parentheses 4 plus 99 parentheses. So we're going to do our parentheses first. 99 plus 4, which is 103, times our 10, which is 1030. So that means if we would continue to add all of these numbers, filling in the dot dot dots, we're going to get a total of 1030. Let's do one more like that. So for this one, our pattern is 3, 7, 11, and then there's some missing numbers, and then 75. So again, we don't know how many terms there are, so we need to find that first. So we're going to use this first equation to solve for n. So we're going to plug in what we do know. We know our first term is 3, so we're going to plug in 3 for a to the 1. We know our common difference is adding 4 each time, so we put a positive 4 here. Our n is our missing variable. So then our a to the n, we want to know what this last term is, what term number, so we're going to plug in 75 here to figure out what term number it is. So then from here we start solving for it, so we're going to distribute the 4. So we bring down 75 equals 3 plus 4 times n is 4n, 4 times negative 1 is negative 4. We're going to combine our like terms, so 3 minus 4 is negative 1. Add our 1 on both sides, so then we get 76 equals 4n. Divide by both sides by 4, and we get n equals 19. So that's telling us there's a total of 19 terms if we fill in the number in between. So then from here we want to find the sum of those 19 terms. So we're going to plug in 19 for our n's. This s to the 19 just means what is the sum of the 19 terms. That's what we're trying to solve for. Then 19 divided by 2, we'll just leave that. Our a to the 1 is what is the first term, so 3. Our a to the 19, is what is the 19th term, so that's 75. So we just plug in our first term and our last term. And then we're going to go through and simplify this. So 19 divided by 2 is 9.5. 3 plus 75 is 78. So we're going to go through and multiply those, and we get 741. So that is the sum of those 19 terms. Now this next type of problem, they want us to write the series in summation notation. So we have our summation notation over here on our formula sheet. So we have this summation symbol. We're always going to have n equals 1 down here. Our a to the n goes over here to the right, and our number of terms goes then on top. So we're going to use this first equation and solve for our a to the n. So a to the n equals a to the 1 plus n minus 1 times our d. So we're going to just plug in everything that we know on this right-hand side. So our a to the 1, what is our first term? We're going to substitute in 7 because that's our first term. And we don't know how many total terms there are, so we just leave that blank. And then the common difference, notice they're adding 4 each time, so we're going to put a positive 4 here. And we're just going to simplify this right-hand side to see what our a to the n equals. So we'll distribute the 4. So we have 7 plus 4 times n is 4n. 4 times negative 1 is minus 4. combine our like terms. So 7 minus 4, we get positive 3. So our a to the n equals 4n plus 3. So notice we're going to plug this right in here for our a to the n, because a to the n equals 4n plus 3. And then from here, we need to figure out how many total terms there are. So for our a to the n over here, notice I'm going to plug in the last term. We want to figure out, is that the 20th term? Is that the 100th term? What term number is that 207? That last term. So then from here, we're going to keep everything else the same. So we have 207 equals 4n plus 3. So then we subtract 3 on both sides. We get 4n equals 204. Divide both sides by 4, and we get 51. So the 207 is the 51st term. So we're then going to plug that up here on top. So then that's going to be our final answer, and it's going to be formatted like this. N equals 1. This 4n plus 3 goes over here to the right, and 51 goes on top. What summation notation is helpful for? That if we want to find the first term of our series, we can plug in this bottom number. So if we plug in this bottom number 1, 4 times 1 is 4 plus 3 is 7. Notice that's our first term. If we want to figure out what the third term is, we can plug in 3. So 4 times 3 is 12 plus 3 is 15. Notice the third term was 15. And then if we plug in this top number, that should give us our last term. So if we take 4 times 51, notice we get 100 or 204. So 204 plus 3 is 207. So it works. Alrighty, so for this next one, this is our new series. So again, we're going to start with this first equation, solve for our a to the n. So our a to the n equals our a to the 1. So what is our first term? We're going to substitute it, negative 5n plus our n. We don't know how many total terms are, so we're going to leave it, minus the 1, and then our common difference, notice they're adding 7 each time, so we put a positive 7 here. Then we're going to just simplify this right-hand side. So we have negative 5 plus 7 times n is 7n, 7 times negative 1 is negative 7. Combine our like terms, so negative 5 minus 7 is negative 12. So this is what our a to the n is reduced, so we're going to plug that in right in for our a to the n on the right-hand side. And then from here, now we're going to substitute in 268 over here for our a to the n, and we want to figure out what term number that 268 is. So then we're going to continue to solve for it. So we have 268 equals 7n minus 12. Add 12 to both sides, and we get 280 equals 7n. Divide both sides by 7, and we get n equals 40. So 268 is the 40th term. So then we're going to plug in 40 up here for our n. So then our final answer is the summation symbol, n equals 1 on bottom, 40 on top, and 7n minus 12 on the right-hand side. Now if we want to check to make sure we have the right answer, if I plug in this bottom number and simplify it, 7 times 1 is 7, minus 12 is then negative 5. So then that gives me my first term. If I plug in this top number, 7 times 40 is 280, minus the 12 is 268. So it works. And if I want to find any number in between, then I can just plug that in. Alrighty, the last type of problem we're going to go through is finding the sum of a series. So if I give you this summation notation, and I wanted you to find the series of those numbers, then we would go ahead and use this equation right here, this 5n plus 3. So to find the first term of the series, we're going to plug in this bottom number. And so I'm going to take 5 times 1 plus 3. 5 times 1 I get 5, plus 3 I get 8. So my first term of my series is 8. And then I don't know what all of them in between are, but I know if I plug in this top number, I'm going to get my last term. So then if I take 5 times 70 plus the 3, so 5 times 70 is 350, plus 3 is 355. So that's going to be my last term. Now I want to find the sum, so I'm going to use my sum equation. And I know it is an arithmetic series because notice this is in the format of y equals mx plus b. So then it is going to be an arithmetic series. So then from here, the terms are from 1 to 70, so I know there's 70 terms. So I'm going to plug in 70 for my n's. And then 70 divided by 2, I'm going to get 35. My a to the 1, my first term was 8, so I can plug that in. My a to my 70, my 70th term is 353, so I can substitute that in. And then I want to go through and simplify. Make sure we use our parentheses first, add those together, and then divide these. We get 35, and take 35 times this number, and we get 12,635 for our final answer if we would add all those numbers in between. Now, this last one, I want you to make sure before you do these problems that always check to see if this expression on the right-hand side is in the format of y equals mx plus b. Notice this one has an exponent. It is not. So it is not going to be arithmetic. So you are not going to be able to use this equation and find the sum.